Hey guys, how's it going? In the last video, we introduced the topic about oxidation and reduction in organic chemistry by focusing on a few reactions. But in this video, I want to focus on just two, a deep dive in some of the more complicated mechanisms that we'll see in the first semester of organic chemistry with ozonolysis and hydroboration. The first of these two reactions that we're going to look at is hydroboration. This is an oxidative pathway for us to get an anti-Markovnikov alcohol. So going from an alkene to an anti-Markovnikov alcohol. It does this through two steps. The first step revolving around nucleophilic addition and a reaction with borane, BH3. The second is a follow-up reaction with hydrogen peroxide and sodium hydroxide. So this is going to help us go from that borane intermediate to the anti-Markovnikov alcohol. So let's start talking about the mechanism. First of all, we're going to talk about that boron has an unhybridized p orbital, even in its boron state. So the alkene is going to react with this molecule, reacting with the hydrogen in borane and the p orbital at the same time. This influences the creation of the borane four-membered ring intermediate. Now, the reason why we get the anti-Markovnikov product throughout this reaction is because of this intermediate. Because it enters in an anti-Markovnikov way, we have a partial positive charge on the more substituted carbon, making the intermediate a little bit more stable. This leaves us with a saturated intermediate involving borane. One of the interesting things is, throughout this first step of reaction, we went from BH3 to BH2 attached to our alkene intermediate. Now, our intermediate can react again and again because that boron is attached to two hydrogens. So when we do these reactions, we actually do them 3 times per borane we have. So if we have 3 alkenes and 1 borane, it will complete the reaction to replace all the hydrogens on borane. So we go from 3 alkenes to 1 BH3 to 1 Br3 intermediate, where the R group is our alkenes. Now that we've finished the first half of this reaction, we're ready for the second half. This involves hydrogen peroxide and sodium hydroxide. We have our borane alkane intermediate that's going to react with hydrogen peroxide. The way to think about this is that through the reaction of hydrogen peroxide, we're not going to put an oxygen between our alkane and our borane intermediate, or our borane R group. The final step of this reaction is to react our new intermediate with sodium hydroxide. This is going to take our intermediate to boric acid and our anti-Markovnikov alcohol. So in summary, we went from alkene reacting with BH3 to create Br3. Br3 is going to react with hydrogen peroxide to form an intermediate that's going to react with sodium hydroxide to form boric acid and our anti-Markovnikov alcohol. Hydroboration is a really unique reaction mechanism, and this is why we decided to take a deep dive on it. We're going to see in the future, definitely when we talk about alkynes, that we can even create other products besides an alcohol using borane. Second reaction we're going to look at is another oxidative pathway. This is called ozonolysis. It's a cleavage of that double bond in the alkene. Remember, we're going to create 2 oxidative products, and it's based off how many hydrogens the double bond carbons have. If we have 2 hydrogens on a double bond carbon, we're going to form formaldehyde. 1 hydrogen, we're going to form a aldehyde, and 0 hydrogens, we're going to form a ketone product. So let's look at the mechanism. The mechanism for this reaction is a little bit complicated, but it focuses around forming more stable intermediates from the product of forming a not so stable intermediate. The reaction starts off with the alkene reacting with ozone to form malosonide. Malosonide decomposes to form a new intermediate that's a little bit more stable, ozonide. Dimethyl sulfide reacts with our ozonide intermediate to break apart, cleave the cyclic structure, and it ends up breaking apart to form 3 molecules, 2 of which are our oxidized carbonyls. In the case for the mechanism reaction, we formed 2 ketones, but the reaction that I have listed above with 2-methyl-2-pentene, we formed a ketone and an aldehyde, 2-propanone and 1-propanal. Hydroboration and ozonolysis were the last 2 reactions I wanted to talk about for the reaction trends of alkenes. In the next few videos, we're going to start talking about the reaction trends of alkynes, triple bonds. Remember, all the infographics that you see me use throughout this video can be downloaded through the link in my YouTube description. Hope it helps.